So if I have a 1 kilogram rock and I take it to the moon, what's its mass? It's 1 kilogram. What's its inertia? 1 kilogram's worth of inertia. See, mass doesn't change no matter where I go. If I go to Jupiter, everything weighs more. It has more gravity, doesn't it? But not more mass. Okay, you had your time. Somebody had a hand up and I didn't answer the question. Yes? Okay. All right. Could you guys try not to go to the restroom during class? All right? That's why we have breaks and stuff like that. I know we don't have a break today. All right, well, let's go over here. And so matter, what kind of things are not made of matter? Well, they have light and sound and heat and all the forms of energy, right? So if you're studying chemistry, if chemistry is a study of matter and the changes in matter, we need to know what kind of things are matter. All right, now, humans like to classify. This is one way that you can classify matter. You can say that matter is either a pure substance or it's not a pure substance. And their definition of the word substance says there's only one way to make it. Now, what's the fancy way of saying that? The books will say it has a constant composition. Now, there are only two things I know of that fit this category. If you are a pure substance and there's only one way to make you, you're either a what or a what? You're either an element or a compound. There's only one way. Now, look up here. See? How do I know if something's an element? It's on the periodic table of the elements. That's easy. And they have these chemical symbols, don't they? These are called chemical symbols. Wow. All right. And by the way, did you know how many different kinds of atoms do we know of? Right there. About 118? This is the periodic table of the different kind of atoms we know of. There is no such thing as an atom of water. How do I know? It's not up there. How about an atom of steel? No. How about an atom of air? No. How about an atom of carbon? Yes. How about an atom of water? Did I say water before? Okay. No. There's no such thing as an atom of water. But now, what other things are pure substances besides... Oh, by the way, I'm sorry. Elements are only made of one kind of atom. If I had a little piece of gold here, it might be a billion atoms. But each of those atoms are what kind of atoms? Gold. It's only made of one kind of atom. Now let's go over here. Another pure substance would be called a compound. That means you have two or more atoms, and how are they joined together? Some kind of a bond, right? What did you learn in middle school? Did you learn about ionic bonds and covalent bonds? Have you heard of those? There's a real chemical bond holding them together. You get that? And the reason it's a pure substance is because there's only one way to make it. How many ways can you make water? One. I need two H's and one O. How many ways can I make glucose? C6H12O6. One. How many ways can I make carbon dioxide? One. So what are the pure substances again? Of everything you can think of, the only things that are pure substances are what? Atoms are elements, right? Elements and what? Got that? And why they're pure substances? Because there's only one way to make them. Now, what does that mean for everything else? Everything around you. Like, see, look at that shirt he has on. Like, everybody, you like that, don't you? Yeah. You like it. And, all right, anyway. What is that? Is that on the periodic table? No. Pink shirt? No pink shirt. Is there a chemical formula? Is there a chemical formula for that? No. So what does it have to be? If you're not a pure substance, what are you? A mixture. That's a mixture. Look at your skin. Is skin on the periodic table? No. Is there a formula for? No. What is skin? Okay. What is a pizza? A pepperoni pizza? Wait a minute. Not on the periodic table. No formula. What is it? There's a lot of mixtures, aren't there? What about air? Oh.
It's on there.
Where? Which one? I don't see it. I don't see it. Air, there's no such thing as an atom of air. So air is not an element. And is there a formula for air? No. So what is it? A mixture. Is everybody with me? So this is how we classify things in chemistry. Now, if you're a mixture, there are two ways to be a mixture. Everybody with me? Tune in on, okay? Two ways to be a mixture. One of them is if I look at you, and I can see more than one thing, then I use the word heterogeneous. Here's one. All right. You remember in biology class using homozygous, heterozygous in genetics? You remember big B was homozygous? Homo means same, doesn't it? And hetero means different? Okay, so look at that right there. Is that on the periodic table? No. Does that thing have a formula? No. But, and I can actually see that it's a mixture, isn't it? Now, is it a heterogeneous mixture or homogeneous? Hetero. Homo means same. That doesn't look the same to me. Don't you see white parts and gray parts? So that's a heterogeneous mixture. Now, we have a lot of those. Your skin, pizza, the shirt, the rocks. We have a lot of those, a lot of heterogeneous mixtures on the planet. Here's a special kind of mixture right here. It's a very special kind of mixture, and even though it's mixed, and you know why it's not a pure substance, when you look at it, you only see one thing. Even under a microscope, it only looks like one thing, but it's not. You mixed it. And why is it not a pure substance? And by the way, have you heard this word? What is a word that means you're a homogeneous mixture? What is that word? You're a solution. Now, if I take a little bit of sugar and put it in some water and stir it up, it looks like the sugar disappeared. But what happened is the sugar mixed and dissolved. Dissolving is not a chemical change. There are no chemical bonds there. It's a physical change. But I've made this stuff called salt water, sugar water, right? Why is sugar water not a pure substance?
It's two things mixed together.
Say it again.
It's like two things mixed together.
Yeah, but these things are two things put together, but they're held together with chemical bonds. Are these held together with chemical bonds? No. And guess what? How many ways can I make sugar water? No. Any of you who have gone and somebody else's house and drank coffee said, they don't make it like me. How many ways can you make coffee? Many. You can make it stronger, weaker, right? Sugar water. There are many ways of making sugar water. So that's why it can't be a pure substance. One other thing about mixtures, which is kind of interesting. If I ever want to take them apart, I don't have to use any chemical reaction to do it. I can do it with physical means. That's what my demonstrations are going to be on Monday. So how do you take this apart? How would you take water apart? Or how would you take glucose apart? The only way to take a compound apart is what? What do you think? Remember you took notes on chapter 3? Do you remember where it said, remember we had physical change, chemical change?
Yeah.
Okay, so think about this. I can separate anything in a mixture. What if I had a salad here? Tomato, carrot, lettuce. Did I use a chemical reaction there? No. I can even separate salt from water. Give me a bowl of salt water. I'll leave it over the weekend, leave it here. And when you get back, the water will be over somewhere else, and the salt will be in the bowl. Did I have a chemical reaction there? No. All mixtures can be separated by physical means. But you aren't going to separate these unless you do what? What do you have to do to separate things in a compound? You have a chemical reaction, don't you? A chemical reaction to break these down. All right. Now, let's go one more step. Let's take one more step into this special kind of mixture called a solution. Do you think I could take some salt, a solid, and can I dissolve it in a liquid? That's easy, isn't it? If someone asks you, give me an example of a solution. Salt water. That's easy, isn't it? Could I take a liquid and dissolve it in a liquid? That's going to be a little harder for you, isn't it?
Yeah, you can.
I have a bottle over there. Might be over there, maybe in the back here. It says 70% rubbing alcohol. Wow. What's the other 30%? Water. And if you look at it, you cannot tell that it's really a mixture. So what would you call rubbing alcohol, 70% rubbing alcohol? Is it matter? Is it matter?
Yes.
Is it a pure substance?
No.
No. Is it a mixture? Is it a heterogeneous mixture or homogeneous? Homogeneous mixture. Called a what? I don't want to get too much into this, but when people drink alcohol, the bottles will have this stain on there. If it's beer or wine, they'll say what percent is alcohol. Like beer might be, maybe the smallest might be 4% alcohol, all the way up to 6% alcohol for a beer. Wine, some of the wines that are a little cheaper might be 8 or 9%, go all the way to maybe 14% alcohol. Everybody get that? But then they have these other stores, and I can find that in a grocery store. Then they have these other stores that sell, it's called the ABC stores, right? Isn't it funny? ABC. Wait, that's not a kid's thing.
It's forbidden.
It's the Alcoholic Beverage Commission. And our state, the state runs those. I'm from Indiana. The state didn't run it. There was a liquor store. You ran your own. It was like a business, all right? But here, the state controls that kind of alcohol sales. Now, if you buy a bottle in there and it says 80 proof alcohol, cut that number in half, 40. That means it's 40% alcohol. Remember, the wines at the most are about 15% alcohol, and this is what? 40? Oh. You're not talking about drinking a little bit of wine. And they have things you can buy that are 150 proof. Every drink is 75% alcohol. By the way, 100% alcohol can actually kill you. So even the people who were called moonshiners, and they made their own alcohol, they can't just make the alcohol and have somebody drink it. You would kill your customers. They had to water it down, didn't they? And they had to know how to make it, and they had to know how to water it down. And they wanted to make a lot of money, didn't they? So sometimes they cheated people. They didn't put quite as much alcohol, right? Matter of fact, if you put a little gunpowder down on a piece of wood and you drop a couple alcohol that you're trying to sell me, moonshiners, if it didn't light, then it's proof that it wasn't having enough alcohol in it. That's where the word proof came from. Okay, so it's interesting, and I'm going to go one more. We have time?
No.
Oh, we don't. You are right. Wait, no, it says 10:40. No, wait, I'm wrong. It says 11:30. Yeah, it's 11:30 on Friday. 11:30. All right, 2 minutes. Hang on. I'm almost finished here. Ready? There's another kind of solution, not liquid, but how about gas liquid? If you look at a bottle of carbonated drinks, Coke, Pepsi, they purposely have dissolved. They dissolved carbon dioxide into that stuff, and that's called carbonated drinks. Have you heard that before? It's in solution. That's why if you leave it out in room temperature, a lot of the gas will come out of solution, and you drink it a day later and you said it's gone flat because a lot of the carbon dioxide is not in solution anymore. And for me, the most interesting of all the solutions, can you have a metal dissolve in a metal?
Yeah. Mercury.
And it looks, at first you're going to say no, but it's a trick. You melt both of them first, then let them harden. And for example, did you know that 24 karat gold is 100% gold? And I would put in the category of an element, but it's soft. And if you make a necklace out of it, it'll break all the time. So you can't make a necklace out of 24 karat gold. So they make gold, and some other metal, and they mix them, and it's called an alloy. Have you ever heard the word alloy?
Yeah.
And 18 karat gold is 18 out of 24 gold. It's only 75% gold. Now, if copper happens to be cheap, you can mix copper and gold, and it still looks like gold. You can have copper and silver. It still looks like gold. Got that? And then there's 10 karat gold. What's that? That's 10 out of 24, whatever that is on the calculator, right? All right, listen. You've had a good week, haven't you, or not? You feeling good? On that homework, I'm not making you do homework on the weekend. I'm just saying if you want to get started, you can, but I would not wait till like Thursday to do it. That's not good. All right, thanks. Have a nice weekend. Have a nice weekend.